This video lesson will teach you to identify a quadrilateral, place it in the family of plane figures, identify the name, the four sides, and four vertices, tell the difference between a simple and complex quadrilateral, and tell the difference between a convex and a concave quadrilateral. Let's begin. What is a quadrilateral? 4 equals quadra, side equals lateral. A quadrilateral is a plane figure made with 4 line segments closing in a space. The easiest, fastest way to learn about quadrilaterals is to build one yourself. Find 4 straight objects to use as line segments. Straws, rulers, dowels, pens, anything will do, and they do not have to be the same length. If you connect the 4 linear objects at their 8 ends, you have a quadrilateral, a 4-sided polygon. Maybe you arranged 4 sides so the shape looks full, which means you made a convex quadrilateral. Maybe your 4 line segments made a pointy shape like an arrowhead. You made a concave quadrilateral. Usually the 4 sides do not cross each other, making a simple quadrilateral. You could arrange your quadrilateral so line segments cross each other. You have a complex quadrilateral. Quadrilaterals appear in 4 configurations. In a convex quadrilateral, each interior angle is less than 180 degrees, and the 2 diagonals are inside the closed space of the quadrilateral. 2. In a concave quadrilateral, one interior angle is greater than 180 degrees, and one diagonal lies outside the shape. In a simple quadrilateral, the quadrilateral does not cross its sides. It is not self-intersecting. In a complex quadrilateral, the quadrilateral has self-intersecting sides. All quadrilaterals have 2 identifying properties. 1. 4 straight sides. 2. 4 vertices, angles where sides meet at their endpoints. Sides and angles can be equal or unequal. When 2 or 4 sides are equal, you get special types of quadrilaterals, such as trapezoids and rectangles. 2 sides of the quadrilateral can cross each other, a complex quadrilateral, which makes your quadrilateral look like 2 adjoining triangles. All the other 4-sided plane figures derived from the quadrilateral are a rhombus, a square, a rectangle, a parallelogram, a kite, a dart, and a trapezoid. Let's draw a quadrilateral. Use a straight edge or ruler to draw a quadrilateral. Draw 4 line segments so each endpoint touches one other endpoint. Whether you have drawn a simple or complex, convex, or concave quadrilateral, you did it correctly. Draw a simple quadrilateral. Do not let any line segments cross each other. Your simple quadrilateral could be either concave or convex. If 2 sides point inward, you drew a concave quadrilateral. Now, draw a quadrilateral where 2 non-adjacent line segments cross each other. You have drawn a complex quadrilateral. Now let's label your quadrilateral. Each vertex is given a letter, moving in either direction, clockwise or counterclockwise, to the next vertex. Like quadrilateral ABCD, each side of the quadrilateral is then identified by its line segment, AB, BC, CD, DA. Each interior angle uses its vertex letter, angle A, angle B, angle C, angle D. Diagonals can be constructed by connecting opposite, non-adjacent vertices, AC and BD. That's it. A simple quadrilateral is also called a quadrangle or a tetragon. A simple quadrilateral will be symmetrical if it has at least one pair of congruent sides. The complex quadrilateral has other names too: butterfly, crossed quadrilateral, self-intersecting quadrilateral, or bow tie. Let's look at the angles of a quadrilateral. For a simple quadrilateral, interior angles of the 4 vertices add to 360 degrees. For a convex quadrilateral, each interior angle will be less than 180 degrees. For a concave quadrilateral, one interior angle will be greater than 180 degrees. For a complex quadrilateral, interior angles add to 720 degrees because 2 of the interior angles are reflex angles, each greater than 180 degrees but less than 360 degrees. Next up is the diagonals of quadrilaterals. All convex quadrilaterals have diagonals, which are line segments connecting non-adjacent vertices, that is, inside their enclosed space. All concave quadrilaterals have one of their diagonals outside their enclosed space. All complex quadrilaterals have both diagonals outside their enclosed space. Take a look at complex quadrilaterals. You may have noticed that the complex quadrilaterals has self-intersecting sides. In mathematics, though, the angles formed by the intersection are not part of the shape. A complex quadrilateral has two acute interior acute angles and two interior reflex angles. Those two reflex angles will appear to be outside the shape, which can be confusing. They are still considered interior angles. Even though two line segments cross and appear to make two more interior angles, the quadrilateral is still said to have only four interior angles. The self-intersecting line segments do not add two angles to the complex quadrilateral. In this lesson, you learn that a quadrilateral is a plane figure made with four line segments closing in a space. Specific types of quadrilaterals, like the rectangle, trapezoid, and square, have more restrictive definitions. Quadrilaterals can be simple or complex. Simple quadrilaterals can be convex or concave. Quadrilaterals can be symmetrical or asymmetrical. Interior angles of all simple quadrilaterals, convex or concave, add up to 360 degrees. Interior angles of all complex quadrilaterals add up to 720 degrees.